All right, guys, welcome back. Today we're going to be talking a little bit about the pH scale and how we're going to calculate pH and all that stuff. Okay, so far we've talked about what acids and bases are, so we should be able to identify those, be able to identify their conjugate acids and conjugate bases, and also be able to tell if something is a strong acid or strong base or weak acid or weak base. Okay, so let's take a look here. We got a reaction happening. Okay, I've got two water molecules. Okay, and you'll notice that these guys are reacting together. Right, and so they're doing different things here. Okay, if I take a look here, let's just take the one that's on the left. Okay, if I connect it to the H3O plus on this side, right, this guy is picking up an H plus. Right, whereas this other water molecule, let's connect it to the hydroxide over here. This guy is losing an H plus. So just like what we've been doing before when we identify our acids and our bases. Okay, so if we're identifying which one's which here, and we have the water on the left-hand side is gaining H plus, so that makes this guy a base. Right, the one that's on the right, it's losing H plus, making it the acid. Right, and then we have the hydronium ion and the hydroxide ion on the other side. Right, and so the hydronium, that's what's made after the base grabs an H plus, so this is going to be my conjugate acid. And the hydroxide is what's left of the acid after it loses that H plus, so that makes it the conjugate base. All right, so this reaction here, this is what we call the ionization of water. Okay, and all that means is I have a beaker of pure water, right? It's only water molecules inside that beaker. Right? A very small number of those water molecules are going to react together, and they're going to behave like acids and bases. Right? One of them is going to behave like an acid and give up its H plus. Right? Another one's going to behave like a base and take that H plus. Right? And when we do, there's going to be a small number of molecules that are going to turn into H3O plus ions, hydronium, and hydroxide ions. Right? And like it says down here, out of about every 10 million water molecules, only 2 of them are going to be ionizing, right? So it's a really very, very small amount that are doing this. Okay, so one thing to note here is that for every hydronium that I make, I'm also making 1 hydroxide. Right? And that's going to be really important here in a little bit. Okay, so in pure water, right, nothing else in there, the hydronium ion concentration, right, those square brackets here, right, anytime I have something written inside those brackets, this is just another way of saying concentration. Okay, so the concentration of hydronium in pure water is 1 times 10 to the negative 7 molar. Right? Since I'm making 1 hydroxide for every hydronium, its concentration is also 1 times 10 to the negative 7 molar in pure water. Right? So as far as pH is concerned, that means that pure water has a pH of 7. Right? That's right in the middle of our pH scale. Right? So let's take a look and see, right, how do I calculate pH, right? And what's it mean? Like, what do these different numbers tell us about our substances? All right, so coming on down, right, the pH, this is an abbreviation for the potential of hydrogen, right, which doesn't mean a whole lot for us, okay? But what that is telling us is, you know, for every pH number, right, that it changes, right? If I go from, say, 6 to 7, right, the concentration of my H plus is changing tenfold. Okay, so pH 6 is going to be 10 times more acidic than pH of 7. pH of 5 is going to be 10 times as acidic as pH 6, or it'd be 100 times as acidic as pH 7. So every time my pH moves a number, right, then the acidity is going up by a factor of 10. Okay, so how do I know this? How do I calculate this? We're going to use this handy equation right over here. Okay, pH is equal to the negative log of the hydronium ion concentration. Okay, or sometimes you might also see this as pH equals negative log of the H plus concentration. Right? So as far as acids and bases are concerned, H plus and hydronium, right, are the same. Right? We're going to treat them the same way. They're representing the same thing, just a little bit differently. Okay? Just know that, you know, if I'm writing H plus or if I write H3O plus, I'm talking about the same thing here. Okay? So if my hydronium concentration is 1 times 10 to the negative 14 molar, that's going to be a pH of 14. Okay? If I have a hydronium concentration of 1 times 10 to the negative 8 molar, it's going to be a pH of 8. 1 times 10 to the 0 molar would be pH of 0. All right, so you'll notice, right, that's kind of handy, highlighting that way. All right, you'll notice that those powers, right, those are matching up with my pH values. Okay, so a good rule of thumb here is whatever power that times 10 part of the concentration is, right, your pH is going to be pretty close to that. Now these ones are exactly on the money because the first part is just a 1. Okay, but you'll see once we start changing that 1, it's going to give us values that are going to be slightly off. Okay, but it's always going to be near that. Right? It's going to be in the ballpark. Okay, so it's a good way to double check, make sure you did stuff correctly. All right, so in that pure water that we were looking at before, H3O plus and OH minus concentrations, those were equal to each other. Right? And so long as those two concentrations are equal, we say it's a neutral substance. Okay, again, that means a pH is equal to 7. Right? However, if those concentrations start changing, right, if my H3O plus concentration is greater than hydroxide, then that means we have an acidic substance, right? And that means my pH is going to be less than 7. Right? And if it goes the other way, if my hydroxide gets larger, right, then that's going to be a basic substance, and I'm going to have a pH that is greater than 7. Okay, so let's take a look at some examples and let's calculate these out and see what we can do here. All right, so we are using that pH equation, right? pH is equal to negative log of H plus or H3O plus concentration. Right? Or if I want to go the other way, right? If I want to reverse that process to find my H plus concentration, all I have to do is take 10 to the negative pH. Right? So these are two very useful equations here, right? Put a big star, highlight, circle, underline, do whatever you need to do to remember I have to know these equations. Okay, I need to know how to use these. All right, so let's start off with some easy ones here. All right, I'm going to do number 1 here. I'm going to take my hydronium ion concentration. That's given to me 1 times 10 to the negative 3rd molar. What's the pH? Okay, so when I'm plugging this into my calculator, I'm going to use the negative sign. Make sure it's the negative button, not the minus button, right? Some calculators have different ones. Okay, so make sure you're using the negative button. Okay, so I'm going to do negative, and I'm going to hit the log button. It should come up as log. So I'm using log base 10. Okay, and usually that'll have an open parenthesis. And what I'm going to do is I'm going to plug in that concentration. So this is in scientific notation. So remember, we have to do the number out front first. So I'm going to do 1. And then I'm going to hit that second comma button, or that E button, to get the times 10. And it should come up as E. And all I have to do is put in my exponent. Nothing with a 10. Right? I'm just going to do E negative 3. Close the parentheses, press enter. Right? And this should give me a pH of 3. All right, so make sure you plug that in, try it out. If you're not getting 3, try it again. If you're having difficulty with that, stop by and see me, and we can take a look at your calculator and make sure you know how to do that. Okay, looking at number 2. Same thing. I'm trying to find the pH from this concentration, but now we don't have a 1 in front, so I know my number is going to be a little bit off. Okay, but I should be somewhere around a pH of 10, right? Somewhere nearby. Okay, so I'm going to do the same thing. I'm going to plug it in. Negative log of 2.7 times 10, negative 10. Close the parentheses, press enter, and when I do, I get 9.57 for my pH. All right, so again, that's pretty close to 10. It's not quite on the money, but we knew it wouldn't be because our number in front was 2.7. Okay, and also, make note here, I'm not putting any units on here. Okay, pH does not have units. It's just a number. All right, so not too shabby. Let's take a look and see, what do I do if I have the pH and I want to find the concentration of H+. Well, if I'm going to do concentration of H+, I'm going to follow that other equation. I'm going to take 10, and I'm going to raise it to the power of the negative pH, so negative 5.3. Now, never leave it just like this. Always plug it in and calculate that out, right? So if my pH is 5, that exponent is going to be somewhere around 5, okay? So plugging this in, right, I get 5.01. That's the first part, times 10. And then the exponent we have is negative 6. Right? Because this is concentration, I'm going to put molar at the end. Okay? And why don't you guys try out numbers 4 and 5. Right? Pause the video, try calculating those out, and see what you get. All right, so hopefully you've plugged those in, and I'll give you guys the answers here. For the first one, we should be getting 1 times 10 to the negative 5 molar for number 4. For number 5, for part A, finding the pH, negative log of that is going to give me a pH of 4. Negative log of 0.0015 molar is going to give me a pH of 2.82. All right. So far, so good. Why don't you go ahead, pause again, try out 6, 7, and 8. All right, see what you can do with those, and then we'll come back and we'll talk about those ones. All right, let's look at number 6. Trying to find the pH value of the following solutions. All right. So again, we're just going to use that negative log of the H+ ion concentration. So negative log of 1 times 10 negative 12. Okay, and we should be getting a pH of 12. All right, for part B, negative log of 0.045 comes out to be 1.35. All right. Now, for number 7, we are going the opposite way. We're trying to go from pH to concentration. So I'm going to do 10 to the negative pH. So for A, that comes out to be 1 times 10 to the negative 5 molar. For part B, 10 to the negative 12.83 is going to give me 1.48 times 10 to the negative 13 molar. All right, and continuing on here, we got a couple more pHs trying to convert into H+ concentrations. 8A would give me 1 times 10 to the negative 4 molar. And B, that would give me 2.82 times 10 to the negative 12 molar. Okay? So, to summarize, we have a pH scale. Right? In the middle of that pH scale, we have 7, and that's going to be neutral. I'll just put N for neutral. Okay? I'll put 0 on the left, 14 on the right. So anything from 7 down is going to be an acid. Anything from 7 on up is going to be a base. Right? And really all that means is on this side, my H plus concentration is greater than my OH minus concentration. And on this side, it's the opposite. My OH minus concentration is greater than my H plus concentration. Right? And if it's exactly neutral, those two would be equal. Okay, so we should be able to calculate the pH if I give you the H plus concentration, or if I give you the pH, you should be able to go the other way and give me the H plus concentration.